Hi, I'm Dr. Nathan Wilson. I'm a researcher and an archaeologist here at the Museum of Anthropology of Xalapa. I'm here today in Patio 3 next to the Maltrata monolith to talk to you about something that I find very interesting, the Mesoamerican counting system. On this face here, we can see the interaction between a woman here and a man here, possibly a warrior. Now I want to highlight one specific type of element that we see on this monolith, numbers. Right here, we can see the number 7 and the number 8. Now these numbers are combined, each with one glyph, to identify the names of the individuals involved in this scene. On this other face, we can see a temple, and we can see the feathered serpent, Quetzalcoatl. On the other panel right here, we can see the number 1 and the number 4. Now each of these numbers are also combined with a glyph, which gives us the dates of 4 movement and 1 house. The Maltrata monolith was brought here to Xalapa in 1962 by the archaeologist Alfonso Medin Zenil. 2 of its sides, or faces, are carved in relief. Numbers are a common component in the various different Mesoamerican writing systems, and we can find numbers on various forms of art and architecture throughout the region, going back over 2,000 years. Now here in Gallery 2 in the museum, we have a number of examples of sculpture that contain numbers. For example, right here we have a stela from Piedra Labrada, and right here we can see the number 7. Over here, Stela 4, or Stela 4 from Cerro Las Mesas, has the number 5. So numbers were obviously very important in Mesoamerica. They were commonly used in the various different calendrical systems that we find throughout the region across thousands of years. Numbers also played a role as forming part of the names of days, years, people, and toponyms, or features on the landscape. Right here in Xalapa, we have a prominent hill known as Cerro Maclotepetl. The first part of its name comes from Macuili, the Nahuatl word for 5. Here's a model of the archaeological site of Zempoala, which is located here in Veracruz. Now its name Zempoala comes from the word Zempoali, which is Nahuatl for 20. Now obviously numbers were important in Mesoamerica, and so therefore I want to talk about first how numbers were written, and second, how the Mesoamerican counting system functioned. So I assume that most of you watching this video use a decimal counting system or a base 10 counting system, the most common counting system in the world, although not the only system that exists. The Mesoamerican counting system, and here we can see Mesoamerica, now that system is vigesimal. It's a base 20. Now in a decimal system, both the names of the numbers and the way in which they are written reflects that it's a base 10 system. The same is true for the Mesoamerican base 20 system. The names of the numbers and the ways in which they're represented is related or linked to the fact that it is a base 20 system. First, an example to help us step away from the decimal system and try to think of the Mesoamerican system on its own terms. In a decimal system, we have, for example, the number 4,829. This number contains 4 digits, 4, 8, 2, and 9. Both the value of each digit and the position of each digit are important, and we understand the amount that this number represents from a decimal perspective. While we might not always consciously think about it, each digit in this number represents a value in relation to 10. In our example, the 9 simply represents 9. If this number were to increase by 1, the 9 would revert to 0, and we would have to increase the adjacent number 2 to a 3, because we would be completing a group or cycle of 10. The 2 represents 20, or 2 cycles of 10. The 8 represents 800, or 8 cycles of 10 cycles of 10. And last, the 4, which represents 4,000, or 4 cycles of 10 cycles of 10 cycles of 10. The name of this number, 4,829, gives us information about the value of each digit and its position. And the name really only makes sense within a decimal system. While the number 40 is 4 cycles of 10, in a base 20 system, it would be understood as 2 cycles of 20. And it wouldn't be called 40 because that is a decimal specific name. Now back to Mesoamerica. Numbers. So one important question is, how were numbers visually represented? How were they written? Now, this system is vigesimal. It's a base 20. So we're going to start reviewing the numbers. We're going to start with basically the building blocks of this system. The numbers 1 through 20, or se to Zimpuali. Now I'm going to use the names for these numbers in Nahuatl because these names are specific to a base 20 system. And I apologize for my poor pronunciation. Now 0 is used in the Mesoamerican system. We see its presence in the Mesoamerican long count calendrical system, a topic that I will discuss in a future video. Bars and dots are used to write 1 through 19. A bar represents 5 and a dot represents 1. In some parts of Mesoamerica, a row of 5 dots was sometimes used instead of a solid bar to represent 5. Now often the bars are oriented horizontally, most often with the dots placed above. Sometimes the bars are oriented vertically, with the dots to the side. Here on the La Mojara Stela, located here at the museum, we see both horizontal and vertical orientations. So now let's review these important first numbers. Now in a decimal system, we need to learn 1 through 9 to construct any number larger. In this system, well, we need to learn 1 through 19 to construct larger numbers. So we're going to start with those. Before beginning, I just want to mention that there are a number of different Nahuatl orthographies. There's no one shared system that dictates spelling, so many words are written with multiple different spellings. I use the form that I learned. So beginning with number 1, we have se in Nahuatl. This is represented by 1 dot. 2 dots represent 2, or ome. 3 dots for 3, or eyi. 4 dots for 4, or nawi. And for 5, or maquili, we use 1 bar. Now on to 6 through 10. So 6 is represented by a bar and a dot, 5 and 1, or chikwase. 7, a bar and 2 dots, or 5 and 2, chikome. 8, a bar and 3 dots, 5 and 3, or chikweyi. 9 is a bar and 4 dots, 5 and 4, or chiknawi. Finally, maklakli, 10 is represented by 2 bars, each bar 5. It is important to note that 6 through 9 are each represented by a bar and a number of dots. And the number of dots is present in the name of each number. Se, 1 in Chikwase, Ome, 2 in Chikome, Eyi, 3 in Chikweyi, and Nawi, 4 in Chiknawi. The names are related to how the numbers are visually represented. Continuing, we have Maklakli 1 Se, 11, Maklakli 1 Ome, 12, Maklakli 1 Eyi, 13, Maklakli 1 Nawi, 14, and Kashtoli, 15. 11 through 14 are written as 2 bars for 10, but 1 bar represents 5, so 2 bars 10, and 1, 2, 3, or 4 dots. The names of these numbers literally translate to 10 with 1, Maklakli 1 Se, 10 with 2, Maklakli 1 Ome, and so on, reflecting the form in which they are written. Now to finish up these building block numbers, we have 16, or Kashtoli 1 Se, which literally means 15 with 1. Kashtoli 1 Ome, 15 with 2, 17. Kashtoli 1 Eyi, 15 with 3, or 18. And Kashtoli 1 Nawi, or 15 with 4, 19. Now these numbers are written with 3 bars, each representing 5, for a total of 15, or Kashtoli, with the addition of 1, 2, 3, and 4 dots. The names of these numbers reflect this. In a decimal counting system, once you learn 1 through 9, you really only need to learn the multiples of 10 to construct much larger numbers. You learn 1 through 9, then 10, 20, 30, 40, 50, etc. And you can construct a wide range of numbers. Basically the same thing can be done here with a decimal system, using 1 through 19 with multiples of 20. So 20 is Simpuali. This consists of Se, 1, and Puali, which means count, and is understood here to be a count or cycle of 20. 40 in this system is not 4 cycles of 10, but 2 cycles of 20, or Ompuali, Ome, 2, and Puali, 20. Next we have Eshpuali from Eyi, 3, and Puali, 20. Next, we have nakpuali from nawi 4 and puali 20. 100 is makwilpuali from makwili 5 and puali 20. Next we have chikwasempali from chikwase and puali. Chikomepuali from chikome and puali. Chikweyipuali from obviously chikweyi and puali. Chiknawipuali from chiknawi and puali. And finally, 200 would be maklakpuali from maklakli 10 and puali 20. So let's continue with multiples of 20. Now remember that in this vigesimal system, 11 through 14 are treated as 10 with 1, 10 with 2, 10 with 3, and 10 with 4. 16 through 19 are treated as 15 with 1, 15 with 2, 15 with 3, and 15 with 4. Now that continues here with the multiples of 20. Now 220 is 11 cycles of 20. But as 11 is maklakli 1 or 10 with 1, 220 is maklakpuali 1 sempuali, or 10 cycles of 20 with 1 cycle of 20. 240 is 12 cycles of 20. 12 is maklakli 1 ome, so 240 is maklakli puali 1 ompuali. 260 is 13 cycles of 20. 13 is maklakli 1 ehi. Now 260 would be maklakpuali 1 eshpuali. 280, we get to 14 cycles of 20. 14 is maklakli 1 nawi, so maklakpuali 1 nakpuali. 300 is 15 cycles of 20. 15 is kashtoli, so we have kashtolpuali. Now 320, we have 16 cycles of 20. 16 is kashtoli 1 se, so kashtolpuali 1 sempuali. 340, we have 17 cycles of 20. 17 is kashtoli 1 ome. Kashtolpuali 1 ompuali. 360 is 18 cycles of 20. 18 is kashtoli 1 ehi. So kashtolpuali 1 eshpuali. 380, we get to 19 cycles of 20. Now 19 is kashtoli 1 nawi. Kashtolpuali 1 nakpuali. Now in the decimal system, when we get to 100, we just work with 1 through 9 and multiples of 10. When we get from 99 and we're getting up to 100, we're completing 10 cycles of 10. So we have to start working with a larger unit, 100. In the Mesoamerican system, we use 1 to 19 with multiples of 20 to get to 20 cycles of 20, wherein we have to use a larger unit as well, sontli, or 20 cycles of 20. 400, 20 cycles of 20 is se sontli, or 1 and 400. Just as we would use 1 through 9 combined with multiples of 10 and 100 to get to the next larger unit, 1000, in a decimal system, we do something similar with the base 20 system, combining 1 through 19 with multiples of 20 and 400 to get to the next larger unit, 8000, or say shikipili. Now shikipili 8000 is 20 cycles of 20 cycles of 20. And that continues, say shikipili, ome shikipili 2, 8000, and on and on. Also, we have some examples here of how some of these numbers, of these other larger numbers, were written, such as 0 in the Maya region, and 20, 400, and 8000 in the Aztec codices. To finish up, let's go over a few examples of numbers in the Mesoamerican system. Remember, in a decimal system, the names of numbers consist of the number of different multiples of 10, such as how many cycles of 10, how many cycles of 10 cycles of 10, hundreds, how many cycles of 10 cycles of 10 cycles of 10, thousands, etc. In addition, if one of these values is 0, we simply don't use that value as part of the name. For the number 1025, we don't have to include 000 in the name, we just have to omit it. The same is true for the vigesimal system, as we have to determine quantities of different cycles of 20. Values of 0 are also omitted from the name of the number. Now the first number we will look at here is 37. Although in this system it wouldn't be 37. We have to think in terms of 20, not 10. This number would be 20 with 17. Now remember, 17 here is actually 15 with 2. So the number is 20 with 15 with 2. Or simpuali 1 kashtoli 1 omi. Now 794. Here we have to identify the quantity of 20 cycles of 20, the number of multiples of 20, and whatever value under 20 is left. Now, we have one cycle of 20 cycles of 20, or 400, Additionally, we have 19 cycles of 20, or more correctly, 15 cycles of 20 with 4 cycles of 20. And we have 14 remaining, or 10 with 4. This would be Sesontli, 1 Kaxtopowali, 1 Nakwali, 1 Maklakli, 1 Nawi. Last one, 1345, or 1345. In the decimal system, this number has values representing 4 different units: thousands, hundreds, tens, and ones. In the vigesimal system, we have to break it up into units of 400, or 20 cycles of 20, units of 20, and the remaining value under 20. Now here we have 3 cycles of 400, 7 cycles of 20, and 5 more. This would be Equizontli, 1 Chicomepoali, 1 Macuili. So we've reached the end of the video, and if you find yourselves here in Xalapa, Veracruz, well, come visit us at the museum. You can walk around and try to find numbers, on the various sculptures or stela that we have. For example, this stela right here, the La Mojara stela, has a bunch of numbers on it. You can see them pretty well if you come by and check it out. Well, that's it for today. Thanks for watching, and if you liked the video, please share it. Again, I'm Dr. Nathan Wilson, and thanks a lot, and take care.